Hello, and thank you for attending our webinar. Let's get to the meat of the matter, how X-ray technology measures fat accurately, improves yields, and enhances product quality. Let me take a moment to introduce myself. I will be your moderator for today. My name is Cassandra Badat, and I've been the Marketing Communications Specialist for Eagle for nearly 3 years. I have worked in B2B marketing for almost 15 years. I have a bachelor's degree from Loyola University, and I also have an MBA in marketing business from the Florida Institute of Technology. Just to give you some background information on Eagle Product Inspection, we have been producing advanced X-ray inspection and inline fat analysis equipment for over 15 years. And with these years of experience, we deliver continuous protection of your products, safeguarding your brand reputation and, of course, customers' well-being. We have a long history of designing and supporting reliable product inspection solutions for the meat industry. This gives us a unique understanding of the market, enabling us to develop comprehensive inspection technologies to suit your production needs. We also facilitate compliance with international and local food safety standards. Eagle PI delivers proven and highly accurate detection levels, which help increase production line efficiencies and uptime, ultimately ensuring the success of your business. We are headquartered in sunny Tampa, Florida. We have an experienced global partner network so that we can provide trusted local experts committed to supporting you through the lifetime of your inspection equipment throughout the globe. Let me tell you a little bit about today's presenter, Michael Stewart. He is Eagle's Fat Analysis Product Specialist. He is responsible for the introduction of X-ray-based fat measurement technology for the global markets. He is dedicated to helping manufacturers understand the importance and usability of fat measurement technology, as well as assisting them with the selection of fat analysis inspection systems to meet their production requirements. Michael joined Eagle from Avery Weightronics, one of the world's leading suppliers of weighing solutions, where he held the position of European Business Development Manager. Prior to this, Michael was the UK Sales Manager for Emerson Industrial Automation, a global company that offers technologies and expertise to help tackle automation challenges. He has considerable experience in the food and beverage industry and combines this in-depth industry knowledge of technologies with meat applications. And just to give you an overview of today's agenda, Mike will explain how X-ray fat analysis works and examine the advantages and disadvantages of various fat analysis methods. Total cost of ownership is an important topic, so he will review elements for consideration, and he will provide you with questions for potential suppliers. Finally, he will briefly review the Eagle FA3 solution and tell you about its features and benefits. This presentation will last approximately 40 minutes with a live Q&A session immediately afterwards.
Many thanks, Cassandra, and I'd like to add my thanks as well to you all attending this webinar. I appreciate you guys are all very busy, so I hope to make it worth your while. So let's get straight into it in terms of what is the impact of fat variability on your business. Well, first of all, we need to start thinking about what kind of meat are we considering putting through an FA system. Well, all of you will be familiar with where your raw materials come from. And what we see here is a drawing of a cow and the various retail cuts, or its primals, which can be removed, and the bulk of which often end up going towards supermarket shelves. Of course, in the process of producing these primals, a lot of trim is removed. Also, some of these primal cuts are not very popular on the actual supermarket shelves. So the type of meat that we're talking about is everything that goes from a slaughterhouse for further processing. Now, this type of meat, its value is determined by its fat content. And the most commonly used method to determine this fat content is by eye. And it's called visual lean. And indeed, when the meat is sold or purchased, its value is determined by its VL rating. The challenge with this, though, is that by grading the fat content of meat visually, it often leads to a large error, somewhere between 5 or 10% or more. But what is the effect of this error? Well, if we think about what that cost could be to your business, the best way to explain it is with a couple of examples. One of our customers in the US, a company called Lone Star Beef, who are a slaughterhouse, before the introduction of a fat analysis system, they were typically giving away 2 to 3% lean points. What this means is that when they thought they were selling a 90, that is a 90% lean piece of beef, they were actually giving away a 93. Now, of course, a 93, being a leaner product, carried a higher value. So what that meant is that every time they sold a 90 and gave away a 93, they were losing nearly 10 cents a pound. When you scale this up across the overall production volumes of the business, based on 600 head a day, it equated to a loss of nearly $1 million per year. In a processing company in Holland, where we also did a test, this particular manufacturer was producing a product of ground beef which had a fat target of 15%. The different raw materials that were used in the recipe were 80-20 and 90-10. When we ran a test, we found that on the bulk of their batches being produced, there was typically a lean giveaway of just over 2%. And when you consider the actual cost of these two raw materials, we could work out that by adding 400 kilograms more of the fattier, lower cost material and using 400 kilos less of the leaner, more expensive material, we were far more able to achieve the fat target of the recipe and do so at a significantly lower cost. What we can see is there is a difference of approximately 160 euros between the actual target and what could have been produced. And when you scale this up through 10 batches in a day, as per what this manufacturer was running, it equates to nearly 1,600 euros a day, which is 8,000 euros a week, or over 400,000 euros a year. This is what brings us to the very meat of the matter. How can we introduce a fat analysis solution which can ensure that meat manufacturers, that's both slaughterhouses and processors, are not suffering such huge giveaways? The core concept is the introduction of a control loop. When you need to introduce a control loop, you need to introduce a measurement device so that you can actually have clear data about where you are in your production process. Fat analysis machines are indeed measurement devices that can measure the fat content of meat. They can measure the weight of the meat. They can also calculate what the protein and the moisture content of the meat that passes through it as well. And at the same time, check to see if there are any contaminants to that meat that could be harmful for either consumption, for consumers, or could potentially damage machinery further down the production line. But what do we do with this measurement device? How do we build a system? The key point is the development of a complete control system. Many of you might be familiar with a control loop like this in a whole host of different fields, from management to manufacturing. The key principles are that you manufacturers know what you want to produce, you know how to produce it, but we need to have the ability to check what's happening and compare the actual results with where the original plan was, and then also act on those results to modify what the situation is. Let's look at each of these areas in a little bit more detail. In the planning stage, again, you all know what your intended final product is. You all know what your customers are asking you to supply. You know which raw materials you would like to use to satisfy this demand. You would know what cost is of these different raw materials, what the availability is at any particular day in your production time. You'll also understand what the demand is and how this demand can vary to satisfy the production of these final products. All of these pieces of information are available, and you will use them to plan your very production. Additionally, you will know how to produce your final products. What are the processes that you use? What's the equipment that you use? All the various different timings that you go through. You all know better than anybody how to produce your product. Of course, understanding the variation in the raw materials is where the measurement device or the fat analysis machine comes in. We want to understand how what is actually going through the production line is different to what was originally intended. But then, of course, to actually deliver any value to your business, we need to be able to react to the results that the fat analysis machine generates. It is only by going through this process that FA machines, acting as a system, are able to actually stop the giveaways that we demonstrated in the first few slides. What we intend to do now is go through all the various different aspects of how to build a system so that we can ensure we can produce the most appropriate system to suit your production. This will start off with a quick overview of how Xray systems work. So, what are X-rays? Well, they are a physical phenomenon which involves electron release. Electrons are driven by a high potential voltage, and they go from an anode to a cathode and hit a metallic target. As the electron hits the metal target, the particle continues around the circuit, but the associated energy signature is released in the form of X-rays. These X-rays pass towards a detector by passing through the product. A detector is a range of different diodes which can come in various different sizes. They are assembled into a diode array, and they sit in between the tube and the product. So what does this look like in a system? We can see here at the top we have our X-ray tube. We can see here at the bottom, underneath the conveyor, we have our detector. And the red triangle in the center is the fan beam of X-rays created, so that as product travels from the left to the right, we can see which part of the X-ray is absorbed by the product, determined by the actual output from the detector below. We can also then decide what to do with that product as it's passed through. And in this drawing here, we can see that if a contaminant is identified in any of these products, it can be removed from the production line. If we think a little bit about how the actual contaminants are identified in the actual product, we can see, again, a tube, X-ray tube at the top, and a linear array of diodes at the bottom, our detector array. On the left and the right-hand side of the actual fan beam, we can see that none of the X-ray energy generated by the tube is absorbed by any product in the center. And this leads to an output from the individual diodes being very low. This is represented graphically in white. As we move into the center of the triangle below the tube, we can see that some of the actual X-ray energy will be absorbed by the actual product itself. As a consequence, the amount of X-ray energy that arrives at the diode is slightly less than at the outside. Therefore, the output from the individual diode arrays is slightly different, and it's represented in grey. In the center of the actual product, we can see a contaminant. Contaminants tend to be significantly more dense than the goods surrounding foodstuff, and as a consequence absorb more X-ray energy. This means that less X-ray energy arrives at the diodes below the contaminant, and therefore the output from the actual diodes where the contaminant is less. And it is this contrast that we look for when trying to identify contaminants in the images. Of course, this technology is what we use to identify contaminants. We need a more sophisticated technology, still using X-ray, to be able to identify what the fat content is of meat. This technology is called DEXA, Dual Energy X-ray Absorptiometry. Well, what is DEXA? Well, DEXA is a technology that's been used in the medical and security industries for some time. It utilizes two energy spectrums to discriminate between high and low X-ray channels. What this means is we actually have two separate diode arrays, and they are separated by a metallic shield. The metallic shield means that only high-level energy X-rays will pass through to the high-level or 140 kV response diodes. This means that at each individual diode location, we can look at the ratio between the high and the low. By sending this information between what X-ray output comes from the two diodes, we can compare the ratio. And it is this ratio which allows us to determine what is fat and what is lean. Of course, there are several other methods of fat analysis used in the industry. Let's have a look. Well, some of the other methods of fat analysis are SOXLA, which is a benchtop solution typically used in a laboratory, Xray, which is an offline system which does use X-rays, and near-infrared or near-infrared transmission, again an offline method. Let's have a look at each of these in a bit more detail. The lab-based method of SOXLA its roots can be traced back to the late 1800s. Indeed, it is very much the industry standard, and it is extremely accurate. However, only small sample sizes can be taken at any one time. And also, the method of testing is quite slow. It can be expensive, and it's also quite invasive. The Xray mechanism for testing the fat analysis is an offline solution already used in many meat factories around the world. The results are quite accurate, but only a 6 kilogram sample can be tested at any time. Near-infrared solutions are also regularly used in meat factories around the world. These are offline testing solutions, and the results are quite accurate. But again, only a small sample can be tested at any one time. So this leads us to ask the question of what are the problems with sampling? In this diagram here, we're trying to demonstrate the challenges associated with measuring the fat content of a container full of cartons of meat. Typically a container, or a carton rather, is around 27 kilos in weight, and in one full container you would have approximately 600 cartons, so it's impossible to measure them all. By measuring small samples of 16 kilos in various methods, as we've previously shown, could indicate that we only get a representative analysis of approximately 0.02%. So does this truly give us an idea of what the fat content is of the total batch? Likewise, an alternative method is taking cores or core drilling such that a sample can be removed from large blocks of meat. But again, the same challenge exists. The fat content of the meat will not be evenly distributed across that carton. So will the core samples removed be truly indicative of the fat content of the meat? So what we can see is that in all of these methods described, only small sample sizes can be taken. So how representative are any results taken as a consequence of measuring these small samples? In doing so, they're also invasive, expensive, and offline, and also subject to high sampling errors. The conclusion here is that the only way to measure 100% of the meat products is using an X-ray system equipped with DEXA technology. DEXA systems can be accurate to greater than 1 cl, and additionally, they can measure the weight to better than 1.5% accuracy. So what can fat analysis machines offer the meat industry? If we think about slaughterhouses, first of all, if a manufacturer produces product which contains too much fat, they run the risk of receiving a fat claim from their customer, therefore costing money. And as we explained in the previous example, if too much lean meat is actually packed into the actual final product, the manufacturer is literally throwing money out of the window. So the way in which to optimize their production is to tightly manufacture their products to the exact customer specifications. If we think back to the example at the start of the webinar, Lone Star Beef were able to significantly reduce their lean meat giveaway with the introduction of a fat analysis system. Additionally, they reduced their fat claims, improved the consistency of their final products, and also were able to ensure that the final products they produce were free from foreign contaminants. Likewise, when we were discussing the example of a processor in Holland, this particular processor, once a fat analysis system was installed, was able to ensure that the raw materials they bought from their suppliers matched the specification of what was ordered. Additionally, they were able to ensure that they produced to their recipe targets far more accurately and far more consistently. They were able to make far better use of the raw materials they had available, and again ensure that these final products were produced free from contaminants. The layout of that system, as we can see in this drawing here, was where multiple different raw materials, as shown on the left-hand side of your screen, which can be variable in their nature, could be combined so that the final product that is produced is far more consistent. The fat analysis system was able to capture what the variation it was of the raw materials and provide the appropriate feedback to ensure that the final product produced was to the target specification. So this leads us to the next challenge. How do we build a system around an FA machine to deliver the benefits that we're describing? Let's recap on the actual process that we spoke about earlier. It's important to introduce this ideology so that the system that we produce understands what we want to make, how it's going to be made, we can measure where we actually are in the production process, and react accordingly. In order to apply this system, we have a range of different building blocks such that various different types of equipment can be assembled to deliver the benefits we're discussing. At the heart of any system is going to be the FA3 machine. This is the measurement device, and it needs to be reliable and repeatable. We of course need to be able to feed in the different raw materials, so we have a range of different in-feed solutions. If the machine detects a contaminant, we need to be able to remove that piece of meat from the production line. Meat can arrive in various different forms, frozen blocks, fresh, or maybe even it's a carton system. And as a consequence, we've got a range of different rejection devices to suit the material handling challenges of the line required for your factory. Likewise, we have a range of different outfeed solutions. Perhaps this meat needs to be taken to a grinder. Perhaps it's a carton that we need to send to a particular location to produce a pallet. We have a range of different systems. We have a range of different equipment such that they can build the appropriate system to suit your manner of production. In either case, we have a range of different software solutions to tie these pieces of equipment together and link in, if necessary, with your business management systems and provide all the necessary reporting and coordination to link in with your ERP and the appropriate levels of automation, while also providing the various degrees of tracking and traceability so we can be clear of exactly which raw materials arrive in which batches, as well as providing all the necessary reporting functions that your business will need to operate. Let's look at an example. In this system here, we are producing batches of meat of approximately 500 kilos. The raw material will arrive in the bottom left-hand corner and be placed onto the conveyor, which will pass through the machine shown in green here. This large display over the top of the machine will show 4 lines of information. The first line shows what the target is to be produced in the actual crate or dough lab. The second line will display what the running average fat content is of all the meat that is passed. And the third line will show the total amount of weight of meat that has passed through the system. What the operators are therefore able to do is look at the actual feedback from the screen and determine whether or not they should add or remove lean or fat meat such that the final targets match what is desired to be in the actual crate. In this system, the decision on how to react to the results from the machine is made by the operators. As a consequence, this is how this overall system is operating, and that is why we classify it as a semi-autonomous, because it is the operators making the decision on how to react to the results from the machine. Of course, more sophisticated solutions are possible. In this example, we can see a sausage processing system, but the principle is of course the same. Raw materials arrive on the left. This could be fresh meat or frozen blocks. This meat will pass through the machine and the actual fat content measured. These results are fed back into software. This software then determines what additional corrective material needs to be added such that the recipe target can be produced. We can see on the right-hand side of the machine different locations should any product be found to contain a contaminant and where this piece of meat can be sent. All good meat will pass through and be passed onto the in-flight conveyor so that the actual batch can be produced directly into the grinder, therefore optimizing overall production. An alternative solution could be for a carton packing. In this instance, individual cartons of meat pass down from the top right-hand corner of the line and go down through the machine and arrive at any one of these individual channels. This type of system is most commonly found when packing large batches either on pallets or in containers. When the actual desired target is known, an operator is prompted to pick the appropriate pallet from the appropriate lane and placed into the appropriate place to build the actual batch as required by the end customer. So if we think now in some way about how we do build a system around a machine, the key questions you need to ask is, what do you want to make and how do you want to make it? But additionally, what flexibility are you prepared to accept in reacting to these results so you can get back to your desired target? So what will our recommendations be when evaluating different equipment suppliers for supplying FA systems? We believe that there's two primary considerations when considering which type of suppliers to use to develop a fat analysis solution. As we've already discussed, the importance of the results drives everything in terms of a fat analysis system. So the decision about which fat analysis machine to use is a critical one. Additionally, additional items, peripheral equipment is needed to build a system around the machine. So you may ask yourself, do I need to use an integrator? And if I do, which one? Let's think about each of these in turn. In trying to determine which FA machine supplier to use, we have to remember that it is an X-ray machine. So what X-ray experience does that particular manufacturer have? What experience does that machine supplier have in supplying equipment into the meat industry? Additionally, how easy is the machine to use? And most importantly, how accurate and repeatable is the machine itself? It's important that any machine used in a fat analysis system is easy to integrate. Also, what is the expected life of this machine? When introducing any type of X-ray device, or especially an FA machine, the total cost of ownership of that machine is a critical component in determining what the return on investment will be for that solution. And on top of this, can the machine supplier help with developing me an appropriate system to suit my production line? When thinking about an integrator, does the integrator understand the principles that we're explaining in this webinar? Do they know how to develop FA systems? Perhaps they may already be familiar with your production line or industry segment. So let's look now at a couple of the advantages of the Eagle FA3 solution. It's important to recognize that any measurement system can experience drift. Drift is the phenomenon whereby the results generated are different to what was anticipated. And these could come from external factors such as temperature, machine movement, changes in electrical supply perhaps after the initial calibration. All measurement devices will experience some form of drift. As a consequence, regular validation and calibration is needed to ensure that system accuracy is maintained. If this system isn't automated, it can often take 30 to 60 minutes to do offline, therefore affecting machine availability. It's also important to recognize that different calibration profiles might be needed for different raw materials, such as different species. Within the Eagle FA3, there are two important features which help improve production efficiencies. Validate is a function that checks the calibration in approximately 40 seconds to ensure that the accuracy of the results being delivered are as per originally installed. The AutoCal function is a system that can correct for any drift in just under 60 seconds. These two features ensure that the accuracy and repeatability of an Eagle FA3 system is maintained. These functions can be activated by the push of a button on the screen. And every time these functions are activated, an entry into the log is made on board the machine. This means that every event is recorded and can be traced back, giving maximum possible confidence that while the system has been in operation, the results generated have been as accurate as originally installed. The Eagle FA3 also incorporates a function known as Product Switch. This allows for products with different inspection requirements to run on the same line. What this means is that, for example, if different species are passing in the same batch, but require different calibration profiles, the calibration profile being applied can be switched instantaneously so that the appropriate inspection parameters are being utilized. By doing this automatically, it eliminates any downtime required to manually switch and recalibrate for different raw materials, therefore maximizing throughput and product availability. The Eagle FA3 machines are regularly installed in areas where hygiene requirements are quite stringent. Therefore, the machine is very easy to clean. It's simple to dismantle. Indeed, one operator can strip the machine down in less than 5 minutes. The machine is designed to meet IP69 protection requirements. Parts carts are available for the storage and handling of the various different removable components during the cleaning process. The Eagle FA3 is also extremely capable at detecting contaminants. The proprietary image analysis software Simultask uses a range of different analysis techniques, all applied simultaneously, and provides unsurpassed contaminant identification. Additionally, the geometry of the actual inspection components inside the machine, that's the tube and the detector, is in a formation we call upshot. This means that the tube is actually at the bottom and the detector at the top. This brings the detector closer to the tube and enhances contaminant detection over the traditional layout. Additionally, by utilizing an additional type of algorithm, which we call material discrimination X-ray, it helps us to identify typically difficult to find contaminants such as bone. When thinking about contaminant detection, it's important to understand what level of performance you can expect. No supplier can ever promise to identify 100% of the contaminants in your production line because it is simply mathematically impossible to prove. Therefore, Eagle states that the performance level you can expect will be in 95% or more of all analyses performed. We would expect 2mm stainless, 1.5mm lead, 2mm of soda lime glass, approximately 4 to 5mm of an aluminium sphere, and an 8 to 10mm cubed piece of calcified bone to be the minimum level of performance required. Of course, detecting contaminants is only part of the process. You also need to be able to ensure that that contaminant is removed from your production process. It is for this reason that Eagle offers a range of different reliable rejection solutions to suit the material handling challenges of your production line. It's important to note that these rejection systems are controlled by the X-ray machine. Therefore, minimum product rework is required, and they often take up a very small footprint, therefore meaning they are far easier to integrate into the production line. Any FA3 system has to be reliable and repeatable. Indeed, Eagle was one of the original pioneers manufacturing X-ray systems for over 25 years and has thousands of X-ray systems installed in a variety of food applications across a variety of different industries. As I've previously explained, one of the key components within the actual X-ray system is the X-ray tube itself. Eagle uses the ultra-reliable Smiths detection tubes, and this is backed by one of the strongest warranties in the industry. In order to be able to tie systems together, it's important to have a range of different software solutions so that we can manage our recipes and we can compare what we originally intended to produce with the position of our raw materials and understand how to correct back. One of the most important tools in delivering this is in software. Eagle has a family of different software solutions available, which we call Optim. These can calculate and direct corrective action to allow the optimization of the production process. Multiple reports can be produced to provide greater insight into the actual production process of the line. When we feed more data into the production system, or the Optim software, by integrating it with the ERP, even further advancements in optimization are possible. So when we think about system integration, Eagle can handle this in a variety of different ways. You may already have a preferred integrator who understands your production line. Eagle has the experience to be able to work with a variety of different integrators to help you produce the appropriate system needed. Alternatively, Eagle has a range of different integration partners with whom we have already developed a good relationship. Alternatively, we can supply an FA3 machine only to yourselves so that you and your own business can develop the system. One of the most important factors when considering which equipment supplier to use will be the cost of ownership. Let's take a few moments to think about what influencing factors there are in working out the total cost of ownership. Well, what is total cost of ownership, first of all? Well, it's a model used to help assess comparable solutions from different suppliers, but it takes into account all the costs associated with an investment, not just the upfront costs, such as the acquisition and the commissioning and the delivery and setup of the actual machine, but any future costs. What are going to be the costs of keeping the system running? And by considering all of these costs, we're able to understand which system will deliver the best value. The additional piece of information required to undertake a total cost of ownership assessment, of course, is the length of time that the asset will be in operation. This question is often answered by considering how long it will be before the asset costs more to operate than benefits it delivers. Eagle FA3 systems are expected to have a life of at least 10 years in operation. The best way to explain total cost of ownership is often through the iceberg metaphor. The upfront costs, or the visible costs, include the cost of the hardware, any associated software, installation, calibration, and shipping. These types of values are often on the quotation or proposal. Of course, the hidden costs are the costs associated with servicing that machine, servicing that production line, perhaps how much it costs to keep that production line running, any upgrades required to keep it operating, what is the cost of any downtime as a consequence of poor reliability. Maybe you need to consider the cost of spare parts or replacing these parts, again, to keep that actual production line running. Understanding what these prices are and what these costs are is often difficult, and so they can appear hidden. Eagle would always recommend that you consider all costs associated with an installation so that you can actually determine what the real value is of the solution being proposed. So here's some final thoughts. Fat analysis systems allow meat manufacturers for both slaughterhouses and processors to produce your products to the same target and specification consistently. Fat analysis systems can allow you to optimize the way in which these meat products are produced. We can protect your brand and we can protect all of your production equipment, while at the same time finding and removing any contaminants from the production line. I'd now like to thank you all very much for your attention, and I'll pass you back to our moderator, Cassandra.
Thank you very much, Mike, for taking the time to present that to us today. And thank you everyone who has attended the webinar. Before I open the session up for Q&A, I'd like to go over a few housekeeping items with you. We are on all of the popular social media platforms, so please, we invite you to follow us. If you'd like to view some supporting information, you can find customer videos and an FA3 animation on our website, eaglepi.com, or our YouTube channel. If you'd like to explore inline fat analysis in more depth for your specific application, please contact us at eaglesales@eaglepi.com, and we will connect you with a local FA specialist in your area. So with that, I'd like to go ahead and open up the Q&A. Okay, and we have one of our first questions here, Mike, for you, and they would like to know, could you please review the importance of an FA machine in the Plan, Do, Check, Act cycle?
Sure, and it's a good question to kick us off, to be honest, Cassandra. The process that we were trying to explain, it's a control loop. In any kind of control loop, what we're looking to do is measure what the difference is between what we initially planned to do and where we actually are within that production process. So the FA machine itself is that measurement machine. It's the machine which is capturing what the actual fat content is of either the raw materials or whatever kind of meat product is passing through the line. And then on top of that, we're comparing those results with what was the original intention. So that the FA machine itself is critical because all future decisions are based on the results from that machine. So that's why all the issues that we spoke about reliability, accuracy, ease of use, and ease of integration are so critical as we go through that process of working out what a total fat analysis system actually looks like.
Okay, great, thank you. We have another question here. What is the size of the raw material that could potentially be needed to run through an FA machine?
So there are some constraints, unfortunately, about the actual maximum physical size of a product that can go through a machine. The maximum physical height is typically 200 millimeters, whereby if we maintain the actual product, or rather if the product doesn't pass through the machine beyond that height, the accuracy on bulk meat of plus or minus 1 cl or better can be maintained. Now, we do have installations whereby we pass meat through the system which is deeper than this, and we can get within plus or minus 1.5 cl when in these instances. But unfortunately, because the depth of the meat increases as well, the performance levels as shown in the webinar on contaminant detection are a little bit compromised. One of the key advantages that the FA system does have, though, is a very high belt speed. This is why it has such a high throughput. So what this means is, unless you've got an incredibly high throughput in your facility, the likelihood of having to pass meat through at such a high profile is relatively slim.
Okay, thank you. And we do have another question here. What is the average lifespan of an X-ray tube? And also, what is the normal lifespan of an FA machine? I'm not sure if the two go hand in hand.
They're critical, as we were talking about in the section in the webinar in working out what the total cost of ownership is. The lifespan of an FA machine from Eagle as a minimum is 10 years. Unfortunately, of course, some parts will fail, and we very much consider the X-ray tube as an old-fashioned tungsten light bulb. It will fail, but with an Eagle system, it is underwritten by a 5-year warranty. That's because we use these Smith detection tubes, which are ultra reliable. These are tubes that have been used in many, many installations around the world, not just in food applications, but in security and defense and a whole host of different food applications. And as a consequence, the design of these tubes has been able to evolve such that they are ultra reliable, as we've written in the presentation today. So the lifetime of a machine as a minimum is 10 years, and the life of a tube should be a minimum of 5 years, and that indeed is underwritten by a warranty.
Okay, great, thank you. We also have another question here. It says, you mentioned that scanning frozen or fresh products is possible. How is the system adjusted when scanning frozen material?
So sometimes different calibration profiles are required to suit the type of product that's passing through the machine. So it could be frozen beef, and then it could be fresh beef. Now, we do typically see a different calibration profile is required for the different natures of product that are being presented to the system. So what we don't want to try and do is pass the two products through simultaneously. So first of all, we will pass them down the line sequentially, and then we can have a couple of different methods to change the actual calibration profile that's being applied. One of the features that we mentioned in the webinar was the product switch feature. Now this is activated by either a touchscreen button on the actual screen of the machine, or it can also be activated automatically, perhaps by some simulated barcode, sometimes by RFID. There's a variety of different automated ways in which to activate the product switch function, depending on what product is passing down the line.
Great, thank you. We do have another question here regarding the actual machine. Someone's asking, how does it actually measure the fat?
So the fat measurement is performed using the technology that we described of DEXA, which is dual energy X-ray absorptiometry. Now, the important point to recognize is that meat is predominantly made up of 3 primary components, and that is moisture, protein, and fat. Those 3 different areas of the actual meat product itself, we can look through the ratios between the high and the low energy spectras, and we can try and detect the heavier element, and the protein proportion is typically identified through the nitrogen component. So when we are looking at the output signature from the dual energy array and feeding it into our algorithm is looking to see what it's actually looking for, the effective atomic charge of nitrogen. The moisture component is typically remains constant in the meat stuff, except when we start passing products through which have a different age. So, for example, when we pass through beef or veal, we would want to have 2 different calibration profiles, because the moisture content of these 2 different meats, although it's from the same species, will be different as a consequence of its age. So what we can do there is look for the protein, rely on the moisture content being stable, and therefore calculate what the fat is.
Okay, great, thank you. And that leads us into another question we have about the main advantages on DEXA over other non-destructive analysis, such as computed tomography, micro-CT, or ultrasound methods, and particularly for carcass fat evaluation or in primal meat.
So one of the challenges that we look at in terms of carcass evaluation is, first of all, the size of the system is significantly lower. In Australia, there are some trials underway to develop a DEXA-based system so that we can do a full carcass evaluation. To be fair, these trials, in my opinion, are at a relatively early stage, although there is a certain drive from the market, of course, to be able to implement full DEXA systems for carcass evaluation. I don't think they're at the stage yet for acceptance into the industry, and as a consequence, the DEXA system that we currently have, which can accept 100% of all the meat product after it's deboned, that can be introduced now, and therefore all the different meat companies in the world, for either slaughterhousing in terms of the meat that they're packing and processing the meat that's being used, you can start to take advantage of the ability to measure and introduce a system to respond to the measurement. Now, that's not to suggest that in several years' time, DEXA systems which could be used in the slaughter field for carcass evaluation could be available. But as we saw in several of the examples in the webinar, there are significant savings to be made. And so my argument would be, why wait to actually start making a saving to improve the performance of your business?
Yes, indeed. All right, our next question is, how is the Optum software different from what the fat analysis machine already does?
So the machine, or the software that is on the machine, is primarily there to ensure that we get an accurate fat content number. It's there to ensure that any contaminants are identified as the images analysis, and then to ensure that all the results of this analysis can be sent to the appropriate location. And this is when we move into that integration aspect of how we build a system. If we are working with a customer who already has a recipe software or a software-based solution which can handle optimization, there's no real need for Optum. Optum is all about comparing or entering details about what product is to be produced, taking the numbers from the FA machine, and then driving or prompting the appropriate corrective action to get back to the desired point. So Optum is our optimization software. The software, which is predominantly simultask, which runs on the machine, is all about generating accurate and repeatable results.
Thank you very much, Mike. Do we have any other questions coming through? Okay, well, I think that wraps up our Q&A. I'd like to remind everyone to email any remaining questions to eaglesales@eaglepi.com. And so thank you very much all for attending, and have a wonderful day. Goodbye.